Hello everyone. This video is on the Knewton Alta assignment for section 6.4 called Special Products of Binomials. Alright, so in this video I'm going to be doing a preview version of this assignment, so please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are all the same and the structure should be similar, so I'm hoping that watching me do these here helps you in some way when you work on the assignment on your own. Alright, so on the assignment page you should be seeing a title, the mastery bar telling you how far along you've gotten, your objectives. It looks like there are 3 objectives for this particular assignment. Under the current objective there should be a question related to that objective, and at the bottom of every question you should see a feedback button where you can send feedback to Knewton if you wish. You will not have this instructor cheat button, it's for instructors only, but you will have a more instruction button. Right, if you're struggling with a topic or a question, try clicking on this and you'll be taken to a page with further reading or videos to study, and you'll be given questions related to that instruction, and completing those questions will help you progress through the assignment. Okay, so the first objective I'm looking at is square a binomial using the binomial squares pattern. So what is that? All right. So the square of a binomial. Squaring a binomial. Okay, so every binomial has, 2 terms in it. It's a polynomial with 2 terms. So like this, capital A, some term capital A, plus or minus some term capital B. So this is a binomial, and what we're doing in this part of this assignment is squaring this, raising it to the second power. Now remember what it means to raise something to the second power. It means you take that thing, right, take the base in parentheses here, the a plus b, and you multiply it by itself, right? You have 2 factors of that. So this is a plus b times a plus b, and then I hope you remember how to multiply binomials from section 6.3. Right, I would end up multiplying the 2 a's eventually, so I'd have an a squared term, and then I'd have a times b, so plus ab, and I'd have another b times a times b from the outers, right, if you're doing the FOIL method, so there's another ab, and then eventually you'd also see b times b, which is b squared, and then combining like terms, right, these 2 ab terms, we get the following. A squared plus 2ab, 2 times ab, plus b squared. And this is that pattern that they're talking about. So when you have a binomial to the second power, don't distribute powers. Please understand that this is not true. A plus b to the second power is not a squared plus b squared. Too many people make this mistake. Right? Do not distribute the powers. You can't distribute powers. A plus b squared is a squared plus 2ab plus b squared. All right. So there's that 2ab term in the middle. So you take basically this, if you so when they're saying use this pattern, we're going to say what's the first term? of the binomial that's being squared? What's the second term of the binomial that's being squared? And then just go jump to this formula here, right? Replace, just do the first term squared plus 2 times the first term times the second term plus, and then the second term squared. Now if you want, you could also do this with a minus sign. If it was a minus b, then you'd have a minus b times a minus b, and then all this stuff would become minus ab minus ab. I still have plus b squared though, because negative b times negative b would still be positive b squared, and then this becomes minus 2ab instead. Alright, still plus b squared at the end though. The only sign that would change in this final form, this final pattern, is the middle term here, the middle sign. But yeah, this is the pattern that they are talking about. Okay, jumping from here to here. From here to here. Right. So, this first example, and then of course we'll simplify when we're done. All right, so this first example that we're given, let me make sure the whole thing's in there. We're given this binomial, q squared plus 4/7 to the second power. See, it's a binomial to the second power. So I just identify the terms of the binomial. So the first term of the binomial is q squared, so that's going to be like the capital A. Right, so everywhere I see capital A up here, I'm going to replace it with q squared. And then the second term of the binomial that's being squared is 4/7, and that's going to be, capital B. Now you could also, if you want to, write out q squared plus 4/7 times q squared plus 4/7, and then do all the distributing. You can do it the long way. But we're asked to use this pattern. Okay, so this should end up being, and then just jumping to the formula here, a squared. So q squared squared, right? Just replacing all the capital A's with q squared, the first term of the binomial, and all the capital B's with 4/7, which is the second term of the binomial, being squared. So q squared squared, and then plus, because it's a plus here. If there was a minus here, it would just be minus. And then 2 times a, which again is q squared, times b, 4/7, and we'll simplify that product. Then finally plus, and then b squared, or 4/7 squared, right? And then I just simplify this. Now q squared squared is q to the fourth. You multiply those. That was that power rule for exponents. Plus, and then here just multiplying a bunch of monomials. You just multiply the numerical parts. 2 times 4/7 is 8/7 times q squared. And then plus 4/7 squared. 4/7 times 4/7 would be 16/49. Right, and there you go. There's our final product. Now again, if you wanted to write it out, q squared plus 4/7 times q squared plus 4/7, and then multiply all the junk out, do all the distributing and combining like terms, you'd end up with this as well. All right, you'd end up with the same exact thing. And that's what I'm typing in. We had q to the fourth plus 8/7 times q squared, and then plus 16/49. Alright, then after you submit an answer, you'll be told if you're right or wrong. And then you're given some sort of answer explanation. They're using lowercase a and lowercase b. No big deal, right? It's the same pattern though. Make sure you read through the answer explanations just to make sure you understand why something was right or wrong, and hopefully you can learn from your mistakes for future questions. All right, next. Now the other pattern we're going to learn, there was squaring a binomial, that pattern, that formula. The other formula or pattern we're going to learn is on multiplying conjugates using the product of conjugates pattern. So first I want to talk about, what are conjugates. So expressions a plus b and a minus b, these are called conjugates. All right. So basically the same two terms, just with a plus in the middle and minus in the middle, right? That's the only difference between them, is the sign in the middle. So a plus b, a minus b. Now let's look at what happens when we get a product of conjugates. When you multiply two expressions that are conjugates. So if I take, a plus b and multiply it by a minus b, or the other way around, you could do a minus b times a plus b. It doesn't matter what order the factors of a product come in. Now, these are just two binomials, right? This is just multiplying two binomials, and you should know how to do that from section 6.3. Remember, if I were to do all the distributing, I'd have an a squared, and then a plus ab, and a minus ab, and then a minus b squared, right? B times negative b. And then if you combine the like terms, you see positive ab and then negative ab. Those make 0. And I end up with a squared minus b squared. And this is it. This is our formula, our pattern. And this is called a difference of two squares. All right, this is a difference of two squares, or just a difference of squares. Right, something squared minus something else squared. All right, so if we recognize a product as the product of conjugates, we just figure out what a and b are and then pop them into this. That's what they're asking us to do, is use this pattern here. Right. So for example, and then of course, simplify when we're done. So an example of this is, here we have 9 dm minus 9 times 9 dm plus 9. And you see how these are conjugates, these two factors. They are conjugates. Right, they're basically the same thing, except one has a minus in the middle, the other has a plus in the middle. But they both have 9dm and 9. 9dm minus 9, 9dm plus 9. And so that's the a and the b, right, from my formula. All right, a plus b, a minus b. The a, capital A, is this 9dm, and then the capital B is this 9, right? So it's a minus b times a plus b. 9dm minus 9, 9dm plus 9. So now you could do the FOIL method or multiply these two binomials the long way, and do all this and then combine like terms and simplify it. But if you recognize, hey, this is the product of two conjugates, I should end up with a difference of squares. Just replace the a with 9dm and the b with 9, and we get the following. 9dm squared minus 9 squared. And of course, we're simplifying this. Now 9dm squared would be 81d squared m squared minus, and then 9 squared is 81. And there we go. That's all we're asked to do. And again, you can multiply it the long way. Go back to section 6.3. Learn, remember how to multiply polynomials. I mean, you can still do all that stuff, and you'd end up with the same result. It's just this is a little faster if you know the formula, if you know the pattern already. So 81 d squared m squared minus 81 would be the product of those two conjugates. Okay. Alright, so still working with products of conjugates here. So again, I'll write this out underneath the formula I had written out. Alright, we have this product of conjugates pattern up here. And here we're given 8mq minus y times its conjugate, 8mq plus y. So hopefully, again, you recognize this as, a minus b times a plus b, a product of conjugates. So I should end up with a squared minus b squared, or in this case, 8mq squared minus y squared. And in simplifying this, 8mq squared would be 64 m squared q squared minus, and then y squared is just y squared. And there we have it. There's the product of those two conjugates. When you recognize it's a product of conjugates, you jump to the pattern, and you can simplify there real quickly. So 64 m squared q squared minus y squared. All right. Great. All right. Now we're on the other objective that we haven't seen. Recognize and use the appropriate special product pattern. So this one is it's a binomial squared. Right? So I'm going back to that squaring a binomial pattern I wrote up. And I'll pull that page up on paper. That was this pattern here. And I'll write out the example that we're given. We're asked to square t minus 9. Right. So again, a is t, and b you could say is negative 9, or if you use the minus version, just b is 9. Either way, you're going to end up with t squared, and then because there's a minus here, this will be minus, and then 2 times t times 9, right, ab, and then plus b squared, plus 9 squared. And this ends up simplifying to t squared, and then negative 2 times t times 9 would be minus 18t, and then plus 9 squared plus 81. And that's as simple as that gets. Now, of course, you could always do this. Take t minus 9 and multiply it by t minus 9. That's what it means to square. And you would end up with t squared minus 18t plus 81 after all the distributing and combining like terms. I'm just jumping to what I know the pattern to be for squaring a binomial, right? And that's what we're asked to do. Right, so this product is equivalent to t squared minus 18t plus 81. Great. Right, so back to the binomial squares pattern. Again, I got the pattern up still, so I'm just going to jump right to it. Pardon me. So we have a binomial being squared, right? It's 9n minus 4/7 times z. So I'm going to replace the a's with 9n, the b's with 4/7 z, and since there's a minus here, there's going to be a minus there. All right. Oh yeah, this is squared, sorry. This is a binomial squared. So a squared would be 9n, to the second power. Then again, a minus here because there's a minus here. And then 2 times a, so 2 times 9n times b, 4/7 z, and then plus, b squared, the 4/7 z squared. And then, of course, we simplify this. 9n to the second power would be 81n squared. And then 2 times 9 is 36. 18 times 4 would be 72. Not 2 times 9 is 18. Times 4 would be 72. And then sevenths, right? So minus 72 sevenths. And then you still have n times z in there as well, so nz. And then plus 4/7 squared is 16/49. And then you got z squared as well for that last term. There we go. That's as simple as that product will get. Alright, that sum, no like terms. And it's really that simple. It's just plugging into the formula and simplifying. And again, you don't have to use the formula. You can multiply it out the long way and still get the same thing. So this ends up being 81n squared minus 72 sevenths times nz, and then plus 16/49 z squared. Great. All right, then which one do I use? And again here, do I use the multiplying conjugates pattern or the squaring a binomial pattern? This is definitely a binomial to the second power, squaring a binomial. Right, so once again, I'll keep that squaring a binomial pattern up on my screen here. And we'll jump to the problem we're given. This one is, we have in parentheses, you have a binomial a to the 5th minus 7b, that binomial squared. So again, because there's a minus here, I know I'm going to have a minus in that second term. And a to the 5th will replace all the capital A's, and 7b will replace the capital B's. So we have a capital A squared will be a to the 5th squared, and then minus, because there's a minus here, and then 2 times, a to the 5th times, and then capital B is replaced by 7b, and then plus, and then capital B is replaced by 7b, right? 7b squared. And then we simplify. A to the 5th to the 2nd would be a to the 10th, right? Using that power rule for exponents. Minus, and then 2 times 7 is 14, and then you have a to the 5th times b, right? 14 a to the 5th b, and then 7b to the second power would be 49b squared, right? Plus 49b squared, and there's your final polynomial there. So a to the 10th power minus 14 a to the 5th b plus 49b squared. Great. All right. So still squaring a binomial. All right, so I've done a few of these now. I'm just going to kind of talk this one out. So remember that when you square a binomial here, it'd be the first term of the binomial squared. So 7a squared would be 49a to the 4th for the first term. All right, then minus, because there's a minus in here. All right, this is a minus b squared. And then 2 times 7a squared times x. So that'd be 14a squared x minus 14a squared x, and then plus b squared or x squared there. Right. So 49a to the 4th minus 14a squared x plus x squared will be the result of squaring that binomial. Great. All right. And one more binomial to square. Again, I'll just talk this one out. It'll be 4m to the second power for the first term, so 16m squared. And then there's a plus in the middle of that binomial, so then the next term is plus then 2 times 4m times q, so 8mq, and then plus and then q squared. Placing the capital A with 4m and the capital B with q for all these, and there's the resulting square of that binomial. All right. Okay, and then multiplying conjugates. So again, I'll bring that pattern back up. And we'll write this out and do it. Alright, so here was that multiplying conjugates pattern. Multiply two conjugates, you just end up with a difference of squares. So this example I'm given in this question is the following. We have 6v minus 3/4 times mw, and then its conjugate would be 6v plus 3/4 nw, which is what they give us. All right, so these are indeed conjugates. So their resulting product, if you want to do it the long way, go ahead. You'll end up with the same thing. But if you're using the pattern, it's just going to be 6v squared, right? In parentheses, 6v squared, minus, and then the b is this 3/4 mw. 3/4 mw squared, and we simplify. Now 6v squared would be 36 times v squared, minus, and then 3/4 times m times w, all that to the second power. Well, 3/4 squared would be 9/16, and then times m squared times w squared, right, using that product to a power rule. And there we have it. Right? There's our product, simplified, no like terms. Right? Okay, so 36v squared minus 9/16 times m squared times w squared. That should be good. Great. And again, more of the same, just either squaring a binomial or multiplying these conjugates. Here's another multiplying conjugates one. So n minus 3ux times n plus 3ux, right? A minus b times a plus b will be a squared, so n squared, minus, and then 3ux, but to the second power would be 9u squared x squared. And there you go. N squared minus 9u squared x squared would be the resulting product. Alright. So yeah, I'm not going to write these out anymore. I'm just going to speak the pattern out loud. There's only two more problems left anyway. Alright, so another binomial being squared here. So remember, this would be like a minus b squared. That would result in a squared minus 2ab plus b squared, where a is m cubed and b is 8n. So m cubed squared would be m to the 6th for the first term, then minus, and then 2 times m cubed times 8n, that'd be 16 m cubed 8n. M cubed n. 2 times m cubed times 8n would be 16 m cubed n. And then plus 8n to the second would be 64n squared. Great. Alright, I should have one more of these. And once again, it's a binomial squared. Again, they might throw out, this recognize and use the appropriate special product pattern. So far, in all four of the problems I've seen, it was a binomial squared. But remember, they might throw a product of conjugates at you. And remember, a product of conjugates is going to be that difference of squares, a squared minus b squared. But this is going to be a squared plus 2ab plus b squared. Or just replace a with m and b with n. And this ends up being m squared plus 2mn plus n squared. Right, the resulting product, the resulting square of that binomial. And great, and that should be it for this preview version of this assignment. Like I said at the top of the video, the questions I see here may not be the same questions that you see when you work on the assignment yourself, but the objectives are the same, structure should be similar. So I'm hoping that watching me do these here helps you in some way when you work on the assignment on your own. All right, and thank you very much for watching.